Hi everyone, myself Impan IMG studying in Sri Venkateshwara College of Engineering. Today I'm going to talk about TCP segment format. Introduction to TCP segment format. TCP, Transmission Control Protocol, is a core protocol of the Internet Protocol suite. It ensures reliable transmission of data between devices over a network. Understanding the TCP segment format is essential for network engineers and developers. What is a TCP segment? A TCP segment is a unit of communication of TCP. Each segment contains control information and user data. Segments help manage data flow and ensure integrity during transmission. Structure of TCP segment. The TCP segment is structured into a header and a payload. The header contains important control information while the payload carries the actual data. The structure helps in organizing and managing data transmission effectively. TCP header length. The length of the TCP header is specified in 32-bit words. The minimum header length is typically 20 bytes, but it can be longer with options. The header length is crucial for determining where the data payload begins. Source and destination port numbers. The source port identifies the sending application on the sender's device. The destination port specifies the receiving application on the recipient's device. These port numbers enable multiplexing of multiple connections over the same IP address. Sequence number. The sequence number is used to keep track of the order of segments. It helps in ensuring that data is reassembled in the correct order at the destination. This is vital for maintaining data integrity and reliability. Acknowledgement number. The acknowledgement number indicates the next expected byte from the sender. It confirms the successful receipt of segments and facilitates reliable delivery. This mechanism is essential for flow control and error recovery. Data offset. The data offset field specifies the size of the TCP header. It indicates where the data begins in the segment. This information is crucial for parsing TCP segments correctly. Reserved bits. The reserved bits in the TCP header are for further use and are currently unused. They are set of 0 in standard TCP segments. Reserved bytes can be utilized for further protocol enhancements if needed. Control flags. Control flags indicate the purpose of the TCP segment, such as CYN, ACK, FIN, and RST. Each flag serves a specific function in managing the connection state. Understanding these flags is key to grasping TCP's connections management. Window size. The window size field specifies the amount of data that can be sent before receiving an acknowledgement. It plays a crucial role in flow control, preventing sender overload. Adjusting the window size optimizes data flow based on network conditions. Checksum. The checksum is used for error checking the header and data. It helps ensure data integrity during transmission. If a segment's checksum fails, the segment is discarded, promoting a retransmission. Urgent pointer. The urgent pointer indicates the end of the urgent data within a segment. It allows prioritizations of certain data, ensuring timely delivery. This feature is useful for applications requiring immediate attention. Options field. The options field provides additional features and capabilities of TCP. Common options include maximum segment size MSS, and window scale. This field can increase the efficiency of TCP connection when used appropriately. Payload data. The payload is the actual data being transmitted in the TCP segment. This is the user data that applications send over the network. The size of the payload can vary based on applications and network conditions. TCP segment size. The maximum size of TCP segment is determined by the maximum transmission unit (MTU). Segments larger than the maximum transmission unit are fragmented at the IP layer. Proper segment sizing is crucial for optimizing network performances. TCP segmentations and resemble. TCP segmentations involves breaking down large messages into smaller segments. Each segment is sent independently and may take different paths to the destination. At the receiving end, TCP resembles these segments based on their sequence numbers. Connection establishment. TCP uses a three-way handshake for connection establishment. This involves CYN, CYN, ACK, and ACK segments to initiate a connection. Understanding this process is fundamental for TCP communication. TCP flow control. Flow control in TCP ensures that the sender does not overwhelm the receiver. It is managed using the window size and acknowledgement system. This mechanism adapts to the network conditions dynamically. Conclusion. The TCP segment format is vital for reliable data transmission. Familiarity with these structures and fields enhances network understanding. Mastering TCP segments is essential for effective network programming and thank you everyone.